So we were discussing about the statistics since yesterday, and we'll be continuing the same session. All right. And today we are going to start with the mathematics part uh, of the probability distributions which we had discussed yesterday. Okay. So initial part will be little bit of mathematics. Okay. Once we cover that, then we'll move ahead and we'll resume what we were discussing in the yesterday session. Okay, so let's quickly look at the distribution equations once. We are going to apply those equations and we are going to solve some problems. All right, so that's what is our fundamental idea for the day, right? So let's start with the first distribution. We'll first look at the discrete cases, then we'll move on to the continuous case. Okay, so the first distribution that we are going to today will be the binomial. Okay, let's write the binomial distribution. So the equation, we have seen that, okay, yesterday, but let's try to look at, let's try to recall that again. So this is how the equation looks like. I'll write the meaning later. Okay, if at all I try to find out the probability, capital P stands for probability of X. Using this binomial distribution, if you want to calculate a probability, then we need some more parameters as well. First, let me write the equation, then we'll try to simplify. Okay, so this is n c x p to the power x, and we have q to the power n minus x. So where we have some of the terms coming into picture, x is the probability of obtaining x. Okay, x can be obtaining head, x can be obtaining tail, x can be raining today, x can be not raining today, something like that. Okay, so the probability of that x is equal to, so we have used the term n over there. So n is said to be the number of trials. How many times you make the trial? Like 50 times I toss the coin. Right? So that 50 comes to this n. All right, ncx, right? We know that, right? Npx and ncx. This is the number of combinations, right? Permutations and combinations. Ncx stands for choosing x objects from n objects. How many combinations you have? Okay, so that's what is ncx. So c we cannot write. So we can write the values of p, right? So p is the probability it's called as a probability of, say, success, right? We know that when we discussed yesterday, we simply got introduced to the concept that this binomial is applicable whenever you have yes or no type of answers. I don't have many possibilities in my results. Whenever I conduct an experiment, I'm going to get only two answers, yes or no. It will rain, it will not rain, like that. Okay, so this is the success which we are trying to find. Whatever x you are trying to find, that will be considered as a success. Okay, so what is the probability of that success? We denote it as p. Okay, and we have another term that is q, which is nothing but it is simply 1 minus p, right? This is actually the probability of failure. You can say that 1 minus probability of success is failure. All right, so we can write probability of failure. All right, using them we can calculate this particular probability using the binomial distribution, right? Like this. Okay, so let's move ahead. Now, let me also give you some of the other parameters because this is a distribution, right? Whenever we are going to use the probability, the binomial distribution, we can try to measure the mean of such distribution. All right, so mean is denoted normally by mu or m. Okay, so whichever you are comfortable, you follow that. That is given by, if you want to calculate the mean of right? This, it is simply n into p. Now you see n is there, n is the number of times you repeat the experiment, p is the probability of success, right? Multiply, you get the mean, right? In addition to mean, we can also calculate the variance. Variance of this distribution, normally we call it as a V, right? That is equal to n into p into q, where np is the mean into q gives you the variance. Okay, and if you want to calculate the standard deviation, right, that is denoted by normally sigma. Okay, so the sigma is equal to, this is the root of variance, always the same formula, so I can use root of variance. So variance is npq. Okay, so by using that, we can calculate this. Okay, that's the first distribution. I want you to remember the P of X equation, the mean, the variance, and the standard deviation. Okay, so that's our first objective, right? We will be solving problems based on various types. We'll try to solve various types of problems on. Okay, right? So I hope everyone is clear with the first distribution. Anyway, equations we discussed in the previous class as well, but anyway, so since we have done this now, you should be comfortable with this.
Excuse me, sir.
Yes, Manish.
Sir, sorry, sir. Actually, I've just joined.
Huh.
So just wanted to ask one thing. So we have just discussed this equation. Is there anything else also?
No. Just started with the equations, right? We just wrote these equations. Since we came across these equations already yesterday, no other explanation is given. Okay, just equation,
Okay.
right?
So can you show the second page? So can you show the second page?
There's no second.
So can you show?
No second page, only this much. Okay, that's the maximum movement on my page.
Okay, sir. Scroll down from this standard deviation.
Nothing.
Okay. Thank you so much. Thank you.
All right. So let's start solving some problems based on this, right? So I expect you also to solve along with me, right? You also do the maths, right? Use a calculator or anything you are comfortable with to get the answer. Okay, so simultaneously, I expect everyone to solve, right? If you have an answer before I solve, please put it in the chat. Okay, so don't answer, right? Because others also trying to solve along with us. So let's not go faster, right? So I consider my speed is the common speed everybody is going to follow. So you can definitely go ahead of me, no issues. Put the answer in the chat. Okay, right? Okay, let's start the problem. All right, so this is the problem number one, which we are going to solve. First, we'll look at a particular distribution. We'll try to solve few problems on that. Okay, and this pattern will repeat for each and every distribution. I'm not going to consider each and every possible distribution, right? I'm going to consider whichever is highly important and repeatedly we might use in our future cases. I'll try to solve that. Again, these problems are not mandatory to be solved to go to the next level. But if you solve this, that becomes easy for us. Okay, so I'm trying to make everybody comfortable because everybody may not be from the same background. Everybody may not have solved the problems right in their mathematics which they have studied. Okay, so that's the only motto behind doing this. All right, so the first question, let's say when a coin is tossed, say 4 times. A coin is tossed 4 times. We are supposed to find the probability of obtaining. So this question has a few subsections. So the first section is exactly one head. Part B of the question, at most 3 heads. Okay, and part C of the question, it's at least 2 heads. So this is what is the question. So Now you see, normally when we get a practical scenario such as this, okay, this is the simplest one. We may not get such a simple problem. We may not face such a simple question in real world. But you see, nobody will mention that, okay, which particular distribution you have to follow, right? From the knowledge you already have, you should be able to, you should be in a position to decide that. Now you see, when I toss a coin, tossing coin is my experiment, right? So obviously, you know that I have only two possible, head or tail. So this actually should give you a hint that, okay, I'm supposed to use the particular distribution. That's how you decide. Okay, there is no hint will be given, nothing will be mentioned over there. This is following this particular distribution. Use those equations. No, normally you don't get. Okay, fine. So again, you might see that there are multiple distributions you can apply to solve a problem. In such cases, definitely you will observe that, right? The answers are pretty much close when you get a final. Okay, right. We'll come to that at a later stage. Right now, our intention is simply to solve this. Okay, so let me go back and show the question completely. Okay, this is the complete question. All right. So let's try to solve this. Now, I'll directly write whatever I know from this. Tossing a coin, again, they have not mentioned what are the probabilities because it is assumed that you know. So we already know that getting a head is the question. So getting head is a success. So getting one head, two head, three head is getting so many successes. So according to our convention, the P is actually that particular probability. Okay. Yeah, Gaurav, I answered that question, right? So you should see how many results are possible. Since the results are two, yes or no type, this belongs to the particular case. Okay, so probability is equal to half, right? Probability of success, it's a head because the question says everything is head, 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 right? So I can assume that, okay, I'm looking at the head. That means it is a probability. That's the P I'm talking about. That means Q should be equal to 1 minus P. Definitely this is 1 minus half. So Q is also half. Equiprobable cases. Head and tail occurs with equal probabilities. All right. Again, they have mentioned how many times you repeat, right? You just check. Coin is tossed four times. So repetition, how many times you repeat the experiment is n. So that is equal to 10. 10 is it? Sorry, my mistake. It's 4, 4. Okay, right. So this is the part. Now, so now the question, let's answer the questions one by one. Part A says probability of one head, right? So X is the, right? X is what I'm trying to find out. So let me say probability of finding X equal to 1, right? X is the success I'm trying to find out. Probability of success is equal to half. So apply that. So this is, first let me write the equation, then we'll substitute. This is NCX, probability of any X equal to NCX, P to the power, P to the X, Q to the N minus X. Very simple, right? So simply do this. So this is N equal to 4, C. How many times I'm trying to find out the success? Out of the 4 times you are tossing the coins, I'm expecting what is the chance that you get only one head? In the sense you should get 3 tails, obviously. Okay. So probability of getting one head is also equal to probability of finding 3 tails. You can solve the other method. Whatever you are going to follow, you can calculate for the 3 tails. That all, and that answer will also be equal to this. Okay. Anyway, now our intention is not that, so we'll not solve that part, we'll solve this. If you are interested, definitely go ahead, do the other way around and verify the answer. You should get the same answer. Okay, 4C1 into, so this is P to the power, so P is equal to half to the power 1. You don't have to write, but it's, anyway, let's write since we are substituting, right? And Q is half to the power N minus X. What is N? N is 4. So I'll write 4 minus 1. So, right? Go ahead, calculate, simplify, and get me the answer. All right. So, right, better to go for a calculator. Directly it will give you the 4C1. Otherwise, you may have to solve it, right, in a different approach, right? Not suggested. Directly go to the calculator, use a calculator and find that. All right. So let me use my calculator to get the answer, right? So that is 4C 4C1 into half raised to the power 4 minus 1, that is 3. Okay, so the answer that I'm getting here is 0.25. All right,
Sir, कुछ नहीं दिख रहा.
Yes, anybody? Everybody getting the same answer? 0.25. Simple calculator substitution, so there should not be any mistake. Okay, so that's the first answer. So what is the chance that you get one head when you tossed 4 times, right? That is 0.25. So the next part, see the question number B over there. The question B says at most 3 head. What do you mean by at most 3 head? You may get no head. You may get 1 head. You may get 2 heads, or you may get 3 heads, right? So 4 things are there. You should be adding them up together to get this answer, right? So B, we are trying to calculate probability of, okay, first let me write in the sentence, probability of at most 3 heads. That is equal to, you may get no head at all the 4 could be tail, right? So probability that x equal to 0, first part, plus, right, I may get no heads or I may get 1 head, so that means it is probability of getting x equal to 1 plus, or, right, I may get right, so this is x equal to 2, right, plus probability that x is equal to, right, x equal to 3. All right, so this is what we need to solve. Yes, we have a question how to solve for C1, right? So we have an equation for n c r. Okay, so that is equal to n factorial divided by r factorial into n minus r factorial. Okay, I won't suggest you to go with this equation because in some cases we may end up with 16C8. Then you see this is a bigger method to solve. So that's the equation you need to solve, but I prefer directly using a calculator, okay, where you have the NCX operation available, right? If you have such calculators, directly use it. Otherwise, you will solve using this particular equation, right? Look at the n and r value, substitute in the equation, you will get the answer. Okay, so now you say it is 4 different terms. I need to add 4 different terms to get this answer. Okay, so let me do that. So how do you calculate x equal to 0? That is 4c0 into half power 0 into, this is q to the power. So p is equal to half. This is q to the power 4 minus 0. So that is equal to 4, my first term, plus 4c1. When I do the 4c1, this is half to the 1 and half to the power 3. Ultimately, you see always this half plus half and half power 4 remains throughout. Okay, in this problem, but it's not true always. So plus 4c2 half power 2 half power 4 minus 2, that is 2. Okay, and I'll also add the last term. So this is 4c3 because x equal to 3 is this case, 4c3 half to the power 3 into half to the power 1. Okay, so ultimately you see half to the power 4 is common. Then I just have to add 4c0 plus 4c1 plus 4c2 plus 4c3. All right, so I want you to solve this and get me an answer. Please type the answer in the chat window. So this is the simplified equation. So take half to the power 4 common, and then you write, yeah, I'll come back, just 1 second. 4c0, 4c1, 4c2 plus 4c3. This is what you need to simplify ultimately. Yeah, please go ahead. Who is asking question?
Sir, I didn't get the p part, that how did you calculate p x equals to 0, p x equals to 1? How?
So you see the question says at most 3 heads. So at most means maximum 3 heads you can get out of the 4 tosses. What is the chance that you get maximum 3 heads. Maximum 3 means less than 3 are also possible. Right? You may get no head. That's why x equal to 0. X is the chance of getting, x is my getting head. Okay. So
Okay.
I may not get any head, right? At the most 3 means no head, 1 head, 2 heads, or 3 heads. So you see, I'm trying to get p of x equal to 0, first case, no heads, plus p of x equal to 1, 1 head, p of x equal to 2, 2 heads, p of x equal to 3, 3 heads. So add all those probabilities, you will get the required answer. That's why the equation to calculate at most 3 heads will be like this.
Okay.
Okay, yes. Yeah, so anybody who has the answer, please put your answer in the chat. Meanwhile, I'll try to solve this. Okay, so we'll compare your answer if you have an answer. All right, so this is half raised to the power 4. Then I need to multiply 4c1. Okay, then I need to add to this 4c2. Yeah. So in this case, I'm getting an answer that is equal to 0.9375. If you convert this into a percentage, it says that there is a 93% chance that out of the 4 tosses of the coin, right, you will get there is a 93.75% chance that you will get, right, at most 3 heads. You may get no head, 1 head, 2 head, or 3. It's obvious. Okay, can you verify your answer once, Ruchi? Because 4c0 is 1, 4c1, how much 4c1? 4c1 is equal to 4. Okay, so this is 1, this is 4, this is 6, this is 4. Okay, so when you simplify that and multiply by 0.5 to the power 4, you will get 0.9375. Okay, so that's how we get this answer, right? So let's go ahead, and I'll give time for you to make an attempt for part C of the question. See the part C of the question. What is the probability that you will get at least 2 heads? Right? I'll give you 2 minutes of time. People try to solve at least 2 heads. Analyze what that indicates, and yes, you can try to solve. Okay, you have 2 minutes. Meanwhile, if you have any question, please feel free to ask. We are open for oral questions.
Hello, sir.
Yes, yes, Devendra.
Sir, actually, I'm not able to calculate the value of NCR.
Okay, are you using calculator?
I don't have a calculator, but I'm trying online calculator through the online calculator.
Okay, okay. It should have a factorial available. If you don't have a factorial, then you may not be able to simplify. That's the thing. Okay, so I'll just show you the calculation one. So I want to calculate, let's say 4c1. Okay, so that means it is 4 factorial divided by r factorial, which is 1 factorial, into this is n minus r. So this is 4 minus 1 factorial. Okay, manually you can do, but when the numbers become too large, this equation method is difficult. Okay, so that is 4 factorial is 4 into 3 into 2 into 1 divided by 1 factorial is 1. 4 minus 1 is 3. So I should write 3 factorial, 3 into 2 into 1. So this 3 to 1, 3 to 1 cancel. So your 4c1 equal to 4. Okay, so that's how you calculate the manual calculation works. I don't suggest this, right? Please try to either get a calculator or use a online calculator which has the factorial representation. Normally you have a C representation directly available in the online calculators. Okay, try to find such a calculator where you can directly enter 4C1, you get an answer equal to 4. Okay, I hope that is clear.
Yeah, sir, I'm trying, sir.
Yes, sure.
Yes,
sure.
sir.
Okay, so anybody has answer for at least 2 heads? We are trying to find out at least 2 heads. Yes, Swapnil, please go ahead.
Which on this example, I mean that as a binomial distribution or normal distribution.
Sorry. I didn't get your question. Can you repeat?
Which I mean that which distribution applies on this example? Means binomial or a normal distribution.
Yeah, okay. So I already have answered the question, but I don't mind repeating. You see, when you have only 2 possibilities in the answer, the question says, right? Find the probability of head. Head means it is only head and tail are possible. If you remember yesterday's discussion, right? It should be clear that when you have only 2 options, you will go for the binomial. It's a discrete case, right? Yes or no?
Right, sir.
Okay.
Right.
Yes. Okay. So yeah, I think Ruchi has an answer, right? 0.375 for at least 2 heads. Okay, let's verify that now. So meanwhile, others also, please put your answer in the chat if you haven't. So at least 2 heads means what? Right? At least 2 heads means you should get minimum 2 heads. You can get 2 heads, you can get 3 heads, or you can even get 4 out of 4 heads. So what you are going to use here, this is probability that x becoming equal to 2 onwards. 2 is inclusive here because you see at least 2. So, right, I'm asking a question like you wrote an exam, right? I'm asking a question. What is the probability that you get at least 50%? You mean that 50 or more is fine, right? So at least 2 is the question. So at least 2 means you can start from 2, go all the way till the maximum possibility. So x equal to 2 plus p of x equal to 3 plus p of x equal to 4. Okay, so this is what we want to calculate. Yeah, we have another answer coming up. That is from Devendra. He says 7.5. I suggest you to check the fundamentals of probability. If you remember, probability cannot exceed 1. So 7.5 may not be possible. It can be 0.75. Please verify. Okay. So cannot exceed 1 because we are looking at a probability. Percentage wise, when I speak, I can say that 90%, 30%, etc. But when I say a probability, it should be less than 1 because 1 means it is a definite event and your probability is 100%. All right. Yes, please check that, Devendra.
Sir, can you scroll down, sir, a little bit? What the value of 1 by 2?
Yeah, this one.
Yeah.
Okay.
So what is the this is the value of what is the value of 1/2, sir? And this is a construct basically.
Yeah.
And we have to multiply, right?
So every term you should add, right? So this is addition. These are additions. Okay.
Yeah.
So there is a multiplication. Internally you will multiply, but once you get a term, you will add to the next term.
Okay.
Yes. So Swapnil says 0.6875. I think that's the closest answer, right? Anyway, we'll verify. Okay, so let's try to answer. Right. So this is equal to, so x equal to 2. So this is 4c2 p to the power 2 q to the power 4 minus 2. That's the first term. Plus, right? 4c3. This is half to the power 3 and half to the power 4 minus 3. So that is 1 plus 4c4 half to the power 4 and half to the power 4 minus 4. So that is equal to 0. Right? So simplify this. Once again, it comes something like half to the power 4 into 4c2 plus 4c3 plus 4c4. right? So that is equal to, right? We get 0.6875. So 68.75 percentage, right? If you want to answer in that way, then you can make it 68.75. Otherwise, you see the probability is this. Okay. Everybody followed this method. Everybody is okay with this, I guess, right? If you have any doubt, yes, please ask the question now itself.
Sir,
Yes, please. Yes, go ahead.
sir, I didn't get the common part.
Common part, all right. So just consider what I am highlighting with the red color. Half to the
Okay.
power 2 into half to the power 2 is half to the power 4. Are you okay with the first term? Yes.
Yes, sir.
Next you see half to the power 3 into half to the power 1 is again half to the power 4. Can I take it out?
How?
Yes.
Look, how it become half to the power 4?
Half to the power 3 plus 1, how much? 4. How did you add this?
Okay.
Half to the power 2 plus 4.
Okay.
Right? Half to the
Okay.
power 4 plus 0. Same thing. Take it out.
Okay. Now I get it.
Yes. Absolutely fine. So everybody fine with this method. I'll teach you the other method. You can think in a different way to answer this. Probability of, right? The whole event is always 1, because when you toss a coin 4 times, any one of the outcome will definitely come, right? Probability of getting 1 head plus probability of getting 2 heads. So starting from 0 heads, probability of getting no head, you may get no heads, you may get 1 head, you may get 2 heads, 3 heads, or 4. Sum of them is always 1. You believe that, right? Because it's a definite event. One of them will definitely going to happen. There is no hidden state over there. Like head or tail will definitely come. The coin will not stand like this. It will fall head or tail for sure. That's for sure. So sum of all the possible cases, no head, 1 head, 2 head, 3 heads, or 4 heads, if I add them up, what should be that case? That should be equal to 1 of this. It's a definite event. 1 means 100%. So if you want to calculate at least 2 heads, I know that it is x equal to 2, x equal to 3, and x equal to 4. If you want to calculate that, I can also do this. This is other method, right? I'll calculate and show this. This is probability of at least 2 heads. So I just want to make you to think that what all ways I can solve a problem. That's what is important. All the sum is 1. From that, I'll subtract, right, 2 things, because 2, 3, 4 are what I want. 1 and 0, I don't want to be included. Probability cannot be equal to 1. I don't want 1 head. I don't want no heads. I want only 2 or 3 or 4. From 1, you subtract this, no? You will get this. Try this, okay? P of x equal to 0 plus P of x equal to 1. This is also should give you the 0.6875. All right, because I'm still doing the same problem. So that is equal to 1 minus, it's simple number 1. 1 minus, what is x equal to 0? That is 4c0 half to the power 4 half to the power 0. Okay, 0 and 4, I guess, not 4 0, because x equal to 0, right? So anyway, it's one and same, but I don't want to break the rule while writing. All right, so this is half to the 0, half to the 4, plus this is 4c1 into half to the 1, half to the 4. Okay, so people try to solve this and tell me what answer you get. So it's something like 1 minus half to the power 4 taken common, right? You have 4c0 plus 4c1, right? We will get the same answer. So that is 0.6875. Okay, take your time. I'll give 1 minute to understand this and solve this, right? Meanwhile, if you get any doubt, yeah, please feel to ask. I hope everybody is getting the answer and the concept is also clear. All right. That's fantastic. Let's go ahead. So this is the next question. So now the concept is becoming more and more clearer as we proceed further. All right. So the next question. The probability that a pen manufactured in a company is faulty is 1 by 10. So there is a 1 by 10 probability that a particular pen that is manufactured by a company is defective. Okay. So the question starts like this. So if 12 pens are manufactured find the probability that, so we have 2 or 3 parts over here. Okay, 2 are defective. Okay, then part B of the question, none of them are defective. Part C of the question, at most say 4 are defective. Part D of the question, at least 10 are defective. Okay, I'll show you the complete question. All right, so people can start solving by themselves, absolutely fine. So we'll go step by step. So you see here, now the question is about the given probability is about fault. Okay, finding a faulty item is right called as a success. So X, when I write P of X, that X indicates finding out a defective item. All right, so that's a point you need to remember. So X here, success means finding, when you inspect, finding out a defective piece, faulty piece itself is a success point. Right, so that's what is given. So let's write what is given here. So probability P is given, that is 1 by 10 corresponds to finding a defective piece. Okay, that means Q should be 1, my mistake, sorry, it should be, I try to write the answer directly. So this is actually 1 minus P, so 1 minus 1 by 10, so this should be 9 by 10. All right, then number of times you do repeat, you check a pen, is it faulty, you check, you keep it as a. So finding out the faulty pen is what is the experiment. How many times you repeat? You repeat 12 times, right? Because there are 12 such pens to be inspected. So let's understand n is equal to 12. Okay, so this is the given data. First thing is finding out 2 pens are defective. So part A, it's pretty straightforward. Probability that you get 2 defective pens. So same equation, NCX, P to the X, Q to the N minus X. So N is equal to 12 now. So 12 C2 into P is 1 by 10, 1 by 10 to the power 2 into the other Q. You see, now they are not same. This is 9 by 10 to the power 12 minus 2. So that is equal to 10. Okay, so this is the calculation you are supposed to do now. Right. So once you have the answer, please let me know. Anybody who could solve this? Please give me an answer in the chat. Yes, that's right, Swapnil. We get an answer equal to 0.2301. Yes, approximated to 0.23. That's also right. All right. Okay. So the next part, people try to answer this, right? It says none of them are defective, right? So that means P of X equal to 0, because X is nothing but finding out a defective item, defective piece. And now we understand that there is no defective piece. So that means it has to be 0. So that is equal to 12 C0, 1 by 10 to the power 0, 9 by 10 to the power 10. Okay, all right. So we have an answer 0.2824. Right? Simply substitute this in a calculator, you get the answer directly. All right, that's our correct answer. So let's proceed further. So the next question says at most 4, right? I may get maximum 4 defective pieces. Lesser than that are also considered over here. So, right, so part C of the question, if you want to answer that, I'm trying to find the probability that at most 4 defective. That means there can be no defective. P of X equal to 0 plus P of X equal to 1 plus P of X equal to 2 plus P of X equal to 3 plus P of X equal to 4, right? So we need to do this calculation. So let me write what we are supposed to solve, right? Then I'll give time for people to solve that. Okay, so X equal to 0 means this is 12 C 0, 1 by 10 to the 0, 9 by 10 to the 10, plus 12C1, 1 by 10 to the 1, 9 by 10 to the 9, plus 12C2, this is 1 by 10
Excuse
to
me, sir.
2. Who is asking the question? Yes, Ruchi.
Sir,
Please tell me.
at P is equal, probability of X is equal to 0, 9 by 10 into raised by 12 में आना चाहिए sir.
P of X equal to 0. Okay, so 12C0, which is 1, right? This is
No, sir. No,
Huh.
no, sir. The equation you are writing right now, the first part of the equation, 12C0, 1 by 10 is equal to 0, 9 by 10 is equal to 12, raised by 12. Because our X is equal to 12, na?
Yeah. Sorry. My mistake. I'll correct that. Okay, so I think the same thing should happen earlier also, right? In that case,
Yes, sir.
isn't it? NC n minus X. Sorry, my mistake. I'll correct that. Okay.
Yes.
Yeah. Thank you for
Yes,
correcting me. Thank you. So I think all of them will change accordingly. Please do the modifications. Okay. Right. So here also it should be 12. My mistake. Sorry. I'll correct from the beginning. So this is actually power 12, right? Okay. So 0, this is 12. So this has to be 1. This is 11. Okay. So this is 2. So 9 by 10 raised to the power. So this has to be 10 and 2. Okay. Yes. Plus 12C3. 1 by 10 to the power. Now this is 3. 9 by 10 to the 9, right? And the last term 12C4, this is 1 by 10 to the 4, 9 by 10 to the 8. Okay, yeah. Please calculate, and when you have an answer, please give me the answer. Right? Yeah, so when we solve this, we are getting an answer that is equal to 0.9956. All right, please verify this answer. So let's move ahead. The part D of the question is at least 10 are defective. So 10 or more defective pieces are what we are expecting. All right. Yeah. So Swapnil says 0.9953, pretty much close to the answer which I got. Okay. So the next is at least 10. So 10, 11 or 12 we need to consider. So probability that at least 10 pieces are defective. That means probability that X can be 10, X can be 11, or probability that X can be equal to 12, all of them should be M. So that is equal to 12 C 10, 1 by 10 to the 10, and 9 by 10 to the 2, plus 12 C 11, 1 by 10 raised to the 11, and 9 by 10 raised to the 1, plus 12 C 12, 1 by 10 to the 12, 9 by 10 to the 0. Okay, so this comes to be a very small value, but anyway we have a value, so that is 5.455 into 10 to the power minus 9. This is a very rare event, right? See, the probability is very less. 10 to the power minus 9 means it is very small number, right? So the chance of getting 10 pieces defective, 11 pieces defective, or 12 pieces defective is a pretty small case, right? It's a very less chance. All right, I hope it's clear. Are you getting the same answer, right? I expect you to solve and verify this answer once. Okay, so we'll give 30 seconds. So for those who are still solving, please solve it, and then we'll proceed. Meanwhile, if you have any question, yeah, we are open for the oral questions.
Sir, in the programming languages, is there any kind of a function which do all these calculations for us?
Sorry, using the programming language?
Is there any function which does all these probability calculations for us? Is there any
Probability calculation? No, we don't have a function which does the whole probability concepts. No, we have to write it. Okay, we have to write the program so that it can. We have to apply the logic, and we have. Okay, so none of the methods, none of the functions available will do this job for us. Okay, anyway, we'll come to that in the probability part when you discuss the basic probability as a module, right? We will do that. We'll first discuss the probability concepts and then we will write the code. Okay, so even in the statistics part, we are going to do that at the end. All right. Okay, so before we continue from where we left yesterday, right? We need all these. We need some calculation. We need you to understand the representation. When I say I'm writing a Z over there, I want you to understand what is that Z represented. That's why we are solving the problems specifically. We are taking one session to solve the problems. Okay. Yeah. Please get adjusted to this. Right. So fine. Let's proceed further. So I will move okay, before I move, I will ask a single question. This question has only one part. I want everybody to attempt and give me an answer, okay? Like a quiz question, okay? Right, so this is a simple question, right? Which we all can solve, right? In a consignment, 5% of the products are, say, defective. Right. If we choose 8 products at random, right? What is the probability that one or more products are defective? Yes. Okay, please try to solve this, right? You have 1 minute of time. It's not a complicated problem. Don't go with the complicated way of solving this. Look for the easiest one, right? Look for the simpler way and try to solve. Okay, we have an answer, 0.625. Okay, let's see. Others, please try. So we have another answer coming up, which is 0.524. Okay, that's good. You are trying. I like that. Everybody should try. Okay, irrespective of whether answer is right or not. That's fine. We will get adjusted to the calculation, right, as and when we solve more and more problems, right? Please give an attempt. We'll discuss the answer. Right or wrong, we'll see later. That doesn't matter. Okay, so please try, everyone. I want few more answers. So Swapnil says 0.3365. All right. Anybody? Anyone? One more answer I will expect from you. At least one more answer so that we'll discuss the answer then. So Niranjan says 0.625. All right. So okay, let's go to the answer. So there are 8 products chosen at random. So what they have given, let's write down first. So probability of defective piece is given. So that is 5%. So that is 0.05. 5%. So that means what is Q? The Q will be 1 minus 0.05. So that is 0.95. Okay, fine. So how many times you repeat? You repeat this 8 times. So you see the question, at least one of them should be what is the chance that at least one of them is defective? Which means one or more are fine. Okay, but if you want to go with that approach, it is P of x equal to 1 plus x equal to 2 plus x equal to 3 dot 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 everything up to P of x equal to 8. Correct? You use the other approach which I mentioned. When you want to take
Excuse me, sir.
bigger sum, right?
Excuse me, sir.
Yes, Ruchi, I'll come to you. Just hold on 1 second. Okay.
Okay, sir.
So when we want to do such a calculation, right? What is the other method? I know that sum of all of them, P of x equal to 0, x equal to 1, x equal to 2. When you take a sum, you get equal to 1, right? So our required answer is simply 1 minus P of 0, correct? Because 0, 1, 2, 3, 4 up to 8 I want to calculate, right? That means sum of P of 0 plus 1, 2, 3, 4 up to 8 is equal to 1 means if you want to 1 to 8, take only P of 0 to other side. 1 minus P of 0 is your answer. So simply, easily you can do. This is the easier method. Definitely, if you prefer, you can go to the other. So this is 1 minus, apply the same thing, NCX, so 8C0, P to the power 0, that is 0.05 to the power 0 into 0.95, right, to the power 8. Okay, yeah, simplify this and you will get 0.3366 as the answer. All right, yes, Ruchi, please go ahead.
Sir, how we do this P? Actually, it should be 5% of number of products.
Yeah. So 5% of the products are defective means irrespective of if you take 10, 5% defective. If you take 100, 5% defective. That's all.
So, sir, in this case, we are having 8 products. No?
Yes.
So
yes.
5% of 8 will be, I think.
No. It's like it's the chance, right?
Okay.
It's not true always. There is a chance of getting 5% defective. Normally, 5% of the manufactured goods are defective. Okay, it's like that. So whatever percentage is given, that is the probability of getting a defective product out of the consignment. So that is the P value given. Probability which is given is that. So we should use that as a P value and we should proceed with the calculation. I hope that is clear. Okay, so point.
So in this case, the number of products is not mentioned. We are just choosing 8 products out of the number of products.
Yes.
Right.
Yes.
So 5% of any random, like, so that's why we are taking the probability is 0.5, right?
Yes, 0.05. Correct. 5% is 0.05.
Right.
Perfect. Yes. Any other doubt? All right. So this can be applied for various type of problems.
Q is equal to 0.95. Q is equal to 0.95. वो कहाँ से आया थोड़ा और एक बार समझिए.
1 minus P. Okay. 1 minus 0.05.
Yes.
All right. Yeah, we get many. We can solve many such problems. Okay. So explore further. Take any book which actually has a probability distribution in that, right? And you can try to solve many things. Okay, because binomial is one very important. You will definitely find n number of problems.
Sir,
okay.
Sir, can you scroll up for a second?
Yeah, sure.
Just 1 second.
This question?
No, sir. Last question.
Only this question. Okay, just a second. I'll show you that. Yes,
sir. Thank you, sir. Thank you.
All right. Okay.
Yeah.
Right. So I expect you to solve more problems by your own, right? Explore further, and if you get out, yes, I'm there to answer. All right. Okay. So let's proceed further. I'll move on to the next distribution that we are going to consider today is the Poissons. So yesterday I mentioned when we plotted this, right? We wrote a Python program to plot this, visualize using Seaborn, as well as we try to visualize in Matplotlib, right? So we had an equation over there, right? So the equation that I'm going to write now is pretty much similar to that. I'm using the similar notations. Okay, so there is probability of finding a x depends upon, there is a parameter, let me call it as m to the power x, e to the power minus m divided by, this is x factorial, right? So this is what is considered as, right, a Poisson's distribution, where whenever we try to write the equation in this fashion, so what are the what are the various terms present over there? P of x is nothing but x is, again, I'm trying to find out, right, probability of something. That it can be probability of getting a call, that is x, right? Probability of raining for so much duration of time, that is x. Probability of not raining, if I'm considering not raining as my problem, then that is x. Okay, x denotes that. Here only unknown we have is m, that is going to be the mean, or it's called as a parameter. All right, so let me write the terms required. So mean, mu, is nothing but that itself is the m value what we write in the equation. That means I will be knowing the mean of certain thing that I can substitute as n if I want to model that using a Poisson distribution. Okay, so that's the first thing. Then we will write the variance. Okay, so the variance v is equal to, that's also m. So you see, m is the mean, m itself is the variance. So if at all you want to find the standard deviation, that is a sigma, which is the root of v, that becomes root m. So this distribution is pretty easy to remember. You just remember the equation, and mean and variance are the same parameter n, and standard deviation will be root of m. Right? So when we say we are going to follow the Poisson's distribution, we expect you to remember this. Okay, so just try to remember these set of equations. Okay, I hope, right, everybody is following, everybody is with me. All right, now let's try to solve the first problem based on this concept. All right, okay, so the problem number 1. In certain factory, there is a probability that it's 1 by 500 that a product is defective. All right, the products are supplied in the packets of 10. So 10 products will be put together and you get a packet when you purchase. So in a packet, there will be 10 products. So irrespective of which product it is, that's fine. Okay. Right. Now the question is find the approximate number of packets. Find the approximate number of packets containing part A of the question, no defective. All right. Part B of the question, 1 defective. Okay. Part C of the question, 2 defective. Okay, 2 defective products in a consignment of 10,000 packets. right? So maybe there is a question in your mind that, and once again, the same question will be repeated, like how do I decide, right? There is a trick here. So actually, when the Poisson's distribution is derived, right, we will be starting from the binomial itself, because you see the question pretty much similar, defective or non-defective. So first question that definitely comes in everyone's mind, that why don't I go for the binomial, right? Very much valid question, right? I should answer. Okay, so there is a derivation for deriving this particular equation p of x, right? Wherein we start from the binomial and we try to make the n present in the equation very large. Okay, so look at all the problems we solved earlier. The n was small, like 10, 12, right? Very small number. Now you see, what's the n value here? You can see that n is large, right? So you can see that it's a large number here, right? So we are repeating 10,000 times, right? Out of 10,000, how many will be there? We are trying to find out. So that's one hint that if you know the derivation part, you will be definitely understanding that. But since we have never gone to that level, it's my job to inform you. Whenever the number of times you repeat is too large, directly go for this method, because otherwise you need to keep calculating NCX, NC, right? X will be different values, right? So like that, I need to calculate. Anyway, that's fine. Maybe in this problem, you will be able to do that as well if required, because only x equal to 0 is x equal to 1, x equal to 2 are asked. But if at all any other number comes into picture, you may have to do this tedious. Okay, so that's a hint that we should go for, right? Whenever the number of repetitions are too large, we have to go for the Poisson's distribution, right? Okay, so I think that answers the question in everyone's mind. So let's try to answer this. So see, what is the chance that probability of a blade being defective, right? I'll call it as P. So let me give a notation now. So P is equal to, this is the probability of defective blade, defective product, I guess, right? Yeah, product. Probability of defective product. It is given, it is 1 divided by 500. All right, so I think we can simplify that, right? Let me write it in the required fashion itself. So 1 by 500 gives you 0.02002. Okay, now they have clearly mentioned that out of it, always you are trying to send the supplies in a packet of 10. So how many blades you can expect as a faulty out of 10 blades? 10 into this product, right? So 10 into this probability. So let me write that in a packet of 10, right? It's actually the mean one. Whatever they have mentioned that, okay, 1 by 500 is the case, that is a mean value of the defective product. Some may contain that much, some may contain more than that, some may contain lesser than that, etc. So we should understand that. So that means in a packet of say 10, right, mean number of, so I can write mean number of the defective products. How can I calculate that? It's pretty simple, right? I'll call that as M. That's the mean for me, mean value. So M is equal to, right? It is 10 packets, sorry, 10 in one packet into the probability of defect is 0.002. So that is 0.02. So anyway, out of 10, 0.02 are defective, doesn't make any sense. But anyway, in terms of the probability, I should follow that. Okay. Now you go for the distribution. So distribution is nothing but it's a P of X. P of X is equal to the M to the power X e to the minus M divided by X factorial. All right. Now this is like I'm doing whatever m I calculated, that is for one packet, right? Now out of 10,000 packets, what should be the calculation? What should be the value I'm supposed to calculate using this particular distribution? All right, so my next objective is that let me calculate, right, in a packet, right, in one packet, what is the chance that I'm going to get, right, no defective. For what's the first question? Let me check. Part A of the question, no defective piece, right? In one packet, this much, there is a chance of whatever probability we get, that is the chance that no defective product. Multiply that by 10,000, you get corresponding to the 10,000. Okay, so that's our approach in this particular problem. Okay, so let's calculate this. That is probability of no defective. I'm trying to calculate that. So first let me calculate P of x equal to 0, right? How do you calculate that? Substitute in the above equation, put the same values over there. All right, so that is I think m to the power x, m is equal to 0.02 to the power x, that is 0, into e to the power minus 0.02 divided by, it's a 0 factorial, which is 1. Okay, so denominator is not 0. Okay, denominator is equal to 1. Okay, so please find out this answer. This is simply e to the power minus 0.02. E to the power minus 0.02 is how much? Anybody has the answer? E to the power minus 0.02. E minus, yeah. So it's 0.98, right? So 0.9801, right?
So what's the value of E?
E is actually exponent, right? Do you remember e to the E means, I'll give the exact value, sorry. I know that it is 2.71, but there is more than that. Okay, I'll give the exact value. Just hold on for a second. Okay, this is the exact value. So 2 decimal I am able to remember. So this is 2.71828. There are more terms, but at least this you can use. Okay.
Sir, it's common for every problem.
Yeah, if there is a e to the power, or if you are using e somewhere, that means it's the same term. Okay, you can put e 2.71828. So this is right. This is the chance that there is 98% chance that, right, you don't get any in a packet of 10 products, 98% chance that none of them will be defective, right? But now the question, you see, out of 10,000, right, packets, how many packets will be without any defective piece? So right, out of 10,000 packets, right? So it's actually I just have to do the calculation, that is 10,000 into this number 0.9801. So that is 9,801 packets will be, right? That's a number of packets, right, without any blade being defective. Okay, P of x equal to 0 out of 10,000 packets. So very similarly, our next approach should be P of x being equal to 1. All right, so put the x value as 1 in the equation. 0.02 to the power 1 e to the power minus 0.02 divided by, this is 1 factor. Okay, please try to solve this. So it's actually, we have the answer directly available. Simple calculation is what is expected. 0.02 to the power 1 is that, into e to the power minus 0.02 already calculated, right? So that is 0.9801. So 0.9801 into 0.02 is the expected answer. Simply multiply and get an answer. Yes. So yes, Swapnil. So that is the right answer. 0.0196. That means I need to proceed further out of the 10,000 packets. This will be, right, 10,000 into this number, 0.0196. So that should be equal to 196 packets, right? There is a chance that 196 packets will be coming with one of the product defective. All right. So proceed further. Very similarly, just calculate this. What is the probability that x is equal to 2? So that is 0.02 power 2, okay, e to the power minus 0.02 divided by 2 factorial.
सर ये होगा 0.0392.
So this is just verify your answer, 0.0002. Okay. Then out of 10,000 packets we choose, how many packets will contain 2 defective products? That is equal to 0.0002 into 10,000. So that will be simply 2. Only 2 packets out of 10,000 will be having 2 products, right? That can be considered as a defective. Okay. So any doubt? Any doubt with this particular problem or the approach or this answer? Anything? Any doubt you have? Please feel free to ask. So this is the first problem we solved. So probably you have some doubts. We'll try to clear it now itself. Okay. Anybody? All right. So what we'll do, okay, this is already time. We may not have if we start a problem, we may not be able to solve it. So we'll go for a break. Okay, we'll take a tea break for 15 minutes, and once we come back, we'll resume solving the problems. All right.
But sir, 9801 plus 196 plus 2 is equals to 10,000 होना चाहिए ना?
Sorry,
सर एक प्रोडक्ट
your audio is not clear. We lost the audio in the middle. Can you come back again, please? What's the doubt?
हाँ सर एक्चुअली 9801 plus 196 plus 2 10,000 होना चाहिए ना सर?
No.
एक प्रोडक्ट रिमेनिंग क्यों रह रहा है?
No. There all the 10 can also be defective, right? All 10,000, right? Sorry, all in a packet. Right now we consider 0 defective, 1 defective, or 2 defective. Right?
Yes,
there
sir.
can be 3 defective pieces, 4 defective, 5 defective, 6, 8, 7, 8, 9, 10. When you get all the values, you add, that will become 10. Okay.
Okay, sir.
Yes. So we have not done
one
that.
is remaining.
Whichever is remaining, you calculate that. Then you add the sum. Everything you add it together. Then it will become 10,000. Okay. It will not become 10,000.
So, sir, if it is like 5 defective pieces, then we will calculate x equals to 5. Then whatever we get, we multiply that with 10,000, and we get 5,000. Out of
10,000, how many are defective? You will get that.
Okay.
Okay, like that. So, okay. Anybody? Any other question? All right, so let's break out for a tea break and we'll join at 5:45. So welcome back. We were solving the problems on Poisson's distribution. All right, so let's proceed further. I'll write a question so that we can wait. Meanwhile, we can wait for others to join back. All right. Okay, so this is the next question. All right. So the number of accidents in a year with the taxi drivers. Taxi drivers has a mean value of 3, right? So out of 1,000 taxi drivers, in a city, find the number of drivers with part A of the question, no accidents. Okay, I'll write in because number of accidents in a year. Okay, so no accidents in a given year. This is the first part of the question. And part B of the question, more than 3 accidents in a year. Right, so the number is given, which is 1,000. It's a larger number, so that means that should give you a hint that, okay, is it discrete? Yes or no type? Yes, accident, no accident type. So this has to be a discrete case, and you can go for a Bernoulli's case or the Poisson. So since the number is large, it should give you a idea that, okay, I should follow the Poissons. All right, so let's write the equation once. They have mentioned that the mean is given, so I can say that M value is there. So M, mean values of accident, right, for a driver is 3. Right, it's a mean value. It doesn't mean that there has to be 3 for everyone. Right, so that's the first part. And let's write the P of X. So what is the P of X? Now that is M to the X e to the minus n divided by x factorial. So since we know the value of m, I can even simplify this further. Okay, so that is 3 to the x into e to the minus 3 divided by x factorial. So we know that if we can even further simplify by substituting e to the minus 3. Okay, so just calculate that. E to the power minus 3, right? So I can further simplify and write this as e to the minus 3. I can write, so that is 0.04978 e to the minus 3, okay, into 3 to the x. This we cannot simplify because x is not known, by x factorial. So this is a P of x. So the first part of the question says that out of 1,000, how many drivers will have no accidents in a whole year, right? So I'm trying to answer that part of the question. So this is part A, right? So no accidents means, right, I'm supposed to find out P of x equal to 0. So simply it is 0.04978 into 3 to the power x. So this is 3 to the 0, which is 1 divided by, it's a 0 factorial. All right. So this is same number, 0.04978, right? So out of 1000, right? This has to be 1000 into this number, 0.04978. So when you multiply by 1000, this becomes 49.78. This is a whole number because number of drivers you are expecting. So convert this into the next number. So that is 50. So out of 1000 drivers, 50 of them will have no accident. Okay, fine. I hope this is clear. Any doubt? So divide 3 by 1000, not required, right? So look at our previous one, right? We never divide, right? We multiply. Okay, all right. Proceed further to answer part B of the question. So it says that probability of more than 3 accidents per year. More than 3 means we don't know what is the upper limit, right? So it's obviously I cannot calculate 3 p of x equal to 3, x equal to 4, x equal to 5, x equal to, it's impossible. So you have to apply the other approach, right? So I'll try to give a notation here. P of, right, x is the accidents more than 3, right? X greater than 3 is what they are asking, right? How do you calculate that? It is 1 minus P of x less than or equal to 3, because more than 3 is asked, so 3 is not included. More than 3 means 4, 5, 6, 7, etc. So there is no upper limit for the number of accidents that might happen for a person, right, in a year, right? So that's why we are not able to do the sum of that. X equal to 3 plus 4 plus 5 plus 6, it's impossible. Any number of accidents might be. So for that reason, you see what we are doing here is the alternative approach. 1 minus probability of accidents lesser than or equal to. So that means that is equal to, now this is what we are trying to substitute, 1 minus P of no accident, okay, plus probability of 1 accident plus probability of 2 accidents plus probability of 3 accidents. This is what we need to calculate. Pretty straightforward, right? Let's do that. So this is equal to 1 minus, so calculate, x equal to 0 means, how do you calculate? Anyway, I think we have the answer. Directly you can write it, okay? You don't have to calculate. So that is 0.04978. Okay, that's already there with us. So x equal to 0 we calculate. You can see here. So from here I'm writing this. Okay, this answer is there, which is x equal to 0. So x equal to 1 onwards you do the calculation. Okay, that will save some time. So plus x equal to 1 means this is 0.04978 into 3 to the power 1 divided by 1 factorial, which is 1. Okay, plus 0.04, there is a 9 which is missing. Okay, I'll write that, 0.04978 into now 3 square divided by 2 factorial. Okay, plus, let me write the next term below. X equal to 0, x equal to 1, x equal to 2 we have written, plus x equal to 3 should be written. So that is 0.04978 into, this is 3 to the 3 divided by 3 factorial. This is what we need to simplify. Okay, so that means, let me try to write it in this fashion. So this is equal to, you can take up 0.04978 common, that's there. So this is 1 minus 0.04978, take it common, okay, then this is 1 plus 3 plus 3 square, that is 9 divided by 2 factorial, which is 2, plus 3 cube, right? 3 into 3 into 3, 9 into 3, that is 27 divided by 3 factorial, 3 into 2, so that is 6. Okay. Right. So we have one answer which says 0.5768. Okay. Others also please calculate and try to give your answer in the chat box.
Yes, sir. One roll down.
Yes, Somesh, we cannot hear you.
Sir,
Can you repeat?
Roll. Yes, roll down. One last step. Last to last.
Previous one? You mean part?
Well, yeah. B part.
Yeah,
Yes,
part B. Can you see now?
Yes.
Okay. Yes.
Okay, thank you, sir.
Yeah, sure. Yeah. Anybody else who is getting an answer to this? Yeah, 0.35277. All right. Anybody else? Please put your answers. We'll wait for a few more answers. Okay. Okay, so 0.35. People are getting closer to 0.35, I guess. Okay. Let's check. Okay, Ruchi, you are also getting the same thing, then absolutely fine. So let's. All right, so let's take it as approximately 0.35, right? Anyway, ultimately we will be coming closer to that only. So let me take this is 0.35. I think 352 is also there. 352. Okay. 3528, is it? Okay, let's take it as 3.3528. So out of 1000, right? What would be the answer? This is 1000 into 0.3528, right? So that is 352.8. Approximately convert this into 353. All right, out of 1000 people, right, 1000 drivers which we are considering, there will be 353 drivers having more than 3 accidents. So minimum 4 or more accidents will be there for these many drivers. All right, let's quickly solve another problem on the same based on the same distribution. Okay. So 2% of the fuses, 3% of the fuses manufactured by a factory are found defective, right? Find the probability, find the probability that a box containing 200 fuses has part A of the question no defective fuses. All right, then we'll go to part B of the question. 2 or 3 defective fuses. All right. Part C of the question. This is more than 4 defective fuses. All right, so this is pretty much similar to what we already have done, right? So it's just like a practice problem to you, nothing new to learn over here. All right, okay, so quickly try to solve this. So first thing is that what is the probability? Given probability, we'll write it down. So that is equal to 2%. So 2 by 100. So that gives you 0.02. Right. So calculate the mean number of defective, right? We can calculate that, the mean number of defective pieces. So I can calculate the mean, that is M, is equal to, it's the number is 200, okay, into this probability, that is 0.02, right? How much? 200 into 0.02, that comes to be 4. All right. So what's the next step? Directly write the distribution. P of x can be written as, first let me write the equation itself. It is m to the x e to the minus m divided by x effective. Substitute for m is equal to 4. So this is 4 to the x e to the minus 4 divided by x effective. All right, so let us calculate the e to the minus 4. Yeah, so that is, yeah, I think we have an answer, right? So Swapnil says that this is 0.01831. Okay, let me write that. So that is equal to, right, 0.01831 into 4 to the x divided by x factorial. Perfect. So that is a P of x. Now you see, we can answer the questions one by one. So part A, no defective. So I have to calculate the probability that defective pieces equal to 0, right? So that you definitely get the answer same as 0.01831, correct? Because this is the calculation 0.01831 into 4 to the power 0 divided by 0 factorial. So that comes to be 0.01831 itself. Now again, out of how many? 200, right? So just do that calculation. So out of 200 pieces, right? So I have to do the calculation 200 into 0.01831. All right. Are they asking how many pieces? If that is not asked, then it's not required, right? So then let me just check the question once again. Okay. Yeah. You see here, no need to calculate the number, no need to multiply. Find the probability. That's all they're asking. How many pieces will be defective? No, it's not us. Yeah. Okay. So perfect. We don't have to calculate that. All right. So this is not needed. So don't do the out of 200 or that calculation is not required. All right. So let me just erase that part. Right? So that's the first part. Directly go to part B. So the part B says 2 or more fuses, right? They are defective. What's the probability, right? So 2 or 3. So P of, I should just do this. P of x equal to 2 plus P of x equal to 3. So 0.01831 into, it's 4 to the 2 divided by 2 factorial plus 0.01831 Let me correct that. So 0.01831 into this is 4 cube divided by 3 factorial. Okay, so we have the answer 0.3418. Right, approximately we'll get that answer. Okay, so others, please verify your answers and let me know if you have any differences. And the next part says that part C of the question, more than 4 defective fuses, in the sense more than 4, that is 5 onwards. So anyway, out of the 200 fuses, there is a chance that you can get more than 4, like 5, 6, 7, 8, 9, 10, 11, 12, like that. All the up to 200, there is a possibility. So we cannot calculate that. So in order to answer the part C of the question, you can simply do this calculation. So what is that calculation you are going to do? 1 minus, I just have to calculate the probability that x equal to 0 plus probability that x is equal to 1 plus probability that x is equal to 2 plus probability that x is equal to 3. So it's more than 3 or more than 4? More than 4 pieces. So more than 4 means 5 onwards. So I should add 4 here plus p of x is equal to 4. So this is the calculation we are supposed to do now. That is equal to 1 minus. So you see that 0.01831 is there in each and every term. So take that out. 0.01831, take it out. So in the first term, you have 4 to the power 0 divided by 0. That's just 1. Okay, 1 by 1. So the second term, you see that it's 4 square, right? 4 to the 2 by 2 factorial. Right. Next, 4 to the 3 by 3 factorial plus this is for 0, this is for 1. I think I missed a 4 to the 1, right? Let me correct that. Right. So first term is only 1. After that, I have to write 4 to the 1 by 1, right? Okay, let me write that. So this is 4 to the 1 by 1 factorial. Then the next term is 4 to the 2 by 2 factorial plus 4 to the 3 by 3 factorial and 4 to the 4 by 4 factorial. Okay, yeah. Everybody, please try to solve. All right, let me write the next step as well, so that if at all people missed something, they can verify. 0.01831. Yes, yes, Swapna.
Sorry, you may please.
Sorry, not audible. Can you repeat?
You may please state the correct answer is, because lots of answer is difference. Above my answer is 0.37135.
No, we'll solve. We'll solve. Don't worry. We will solve.
Okay.
We are solving it. Okay. Right. So whenever there is many people give different answers, I will solve. Okay. So this is 1 plus what is 4 to the 1 by 1 factorial? That is 4. Correct. Next value 4 to the power 2. Right. 4 to 4. 16 by 2. That should be 8. Correct. So what is this next number? 4 cube. So 4 cube by 3 factorial. How much?
That's equal to 64. 64 divided by 3.
64 by 6. Okay. So that gives approximately 10.6667. All right. Plus the next number. This is 4 into 4 into 4 into 4. So, right. So that should be 256. Right. Divided by 4 factorial, isn't it? Let's do that. So that gives also 10.6667. Right. So people, go ahead and calculate this now so that you can get a clear answer. Right. So this is now pretty straightforward. I just have to do 1 minus 0.01831. Multiply that with 1 plus 4 plus 8 plus 2 times 10.6667. Yeah. So Whoever got the answer like 0.37, close to that, that is the right answer. All right. So this is 0.371135 approximately. You may get decimal value slightly different. That's absolutely fine. Okay. So those who got around 0.54, kindly verify your answer once again, right? This is the closest answer that we can. Okay, any doubt? We'll give 1 minute time to everyone to verify your answers once. Okay, so take your time, verify, and then we'll proceed. Okay. So since you don't have a doubt, I'll give a homework question. You have to decide which way to, how do you proceed, etc. It's left to you. I'm not going to solve this now. It's simply a homework question. Okay, left to you for giving an attempt. All right, so this is the question. In 800 families with 800 families with 5 children each, how many families would be expected All right, so this is the question, right? Out of 800 families under consideration, each family has 5 children. Okay, how many families you can expect to have? First question, 3 boys, exactly 3 boys. Okay, then exactly 5 girls, then either 2 or 3 boys, then at most 2 girls. All right, so anyway, since we know the concept, I expect you to solve this, right, using a very easy method, right? So you will be able to solve that because we have solved many problems previous to this. All right, so again, you can decide which particular algorithm, sorry, not algorithm, my mistake, which particular distribution you are going to consider, right? You can solve using binomial as well. That's a hint, right? Think how to do that, and right, so you will get the answer right. Okay, so then let's proceed further. Okay, so these two are the major, what you call, distributions we have to consider when we go for the discrete cases. All right, so further I'm going to the continuous case. Okay, in the continuous distribution, the one which we are going to consider is called as the normal distribution. All right. So the normal distribution will have its probability density function. So there is, whenever I try to plot the curve, right, that curve is called as a probability density function, right? So it's, in short, we'll write it as a PDF, probability density function, right? What is the probability of taking a specific value? That actually has an equation. It is f of x, right? F of x is given by, recall, yesterday we actually used the same equation to get the values of a curve. Okay, manually we calculated, we put this equation using a lambda function, we calculated that, obtained the values, and then we plotted. That plot actually matched with the points automatically calculated by the built-in function. Just try to recall. So this is the same function, that is 1 divided by square root of, this is 2 pi sigma square into e to the power, or even you can write exponential, exp, that's also going to work, e to the power minus of x minus mu the whole square divided by 2 times sigma square. All right, here the mean will be simply mu itself. Whatever mu you see in the equation, that itself is the mean value of this function. And so whenever we try to calculate its variance, right, so the variance will be the same value. So I'll write variance. Variance is sigma square. That means the standard deviation is the sigma, root of variance. Okay, so just see this equation, the same equation we used, right? Yes. So whenever we try to plot this, right, how it's going to look like, I'll try to write that. Okay, so let's see. Say this is the x-axis, right? So I'm trying to plot the x along this axis, x values. It can be positive, negative, etc. Assuming that, okay, let me assume that this is the 0, right? X equal to 0 value, that is here, x equal to 0. So what I'm plotting here along the y-axis is the f of x. Okay, f of x is plotted along the y-axis. Now there is a central value around which you have these f of x points are distributed. So that means I'm going to have a mean somewhere here. Again, this is just an assumption. Mean can be negative, no issue. Okay, so at that mean value, you are going to get a highest value. So that is what is this function. You can substitute different values and see. Once you have a value of mean mu available, we can do that. Okay, so what happens? This will look something like this on one side. Even on the other side, we are expecting, sorry, it may not look symmetric on my diagram, but I'll try to make sure that I'm going to make it symmetric. Okay, so may not look symmetric, just pardon me for the drawing skills. All right, so you see that about this particular line, whatever you have on the right side, it's symmetric, it should be symmetric on the left. So this is the plot f of x. So recall what we had plotted yesterday, we got the similar graph, right, when we plotted over there, right? But there is a small difference. So to be technically correct, right, what we actually had drawn over there is called as a standard normal curve. Because if you remember, somebody asked a question, right, what's the difference, etc. I told that the normal curve which we got has 0 mean, correct, and variance equal to 1. That's what was my point. But now I don't see that. That's not happening here. Variance is a sigma square, it's not 1. Okay, and mean is mu, not 0. So right? Technically, mathematically speaking, if you go through the mathematical textbooks, right, first you discuss about the normal distribution, that is this curve. Okay, then we convert this into a standard form that is called as a standard normal distribution. Okay, but in general, the standard normal distribution itself is called as a normal distribution. But I'm going through the textbook method right now because I want to teach everything, right? I don't want to simply stick to the normal curve and I say that it's a 0 and variance is 1. Then when something new comes up, people should not struggle. Okay, so that's my objective. So that's my motto. So I'm starting from scratch. So this kind of curve, if you observe, it's not centered around 0. If you see, this is what is the expected standard normal curve. So standard normal curve should be somewhere here, right? It should be somewhere here. So that the mean becomes equal to 0 and this variance which is expected to be 1, right? So that's what is expected, but that's not going to happen always, right? Whenever you get a data, right, which is normally distributed, that will never be centered around 0. You always get something like this. Okay, it is centered around some mean value. Around that you have the curve coming in the picture. I hope that is clear. This is something like, this is a practically available data set. You collect the data and you observe that it is normally distributed, means you have this kind of curve, not the standard one. Is it okay? I hope I'm clear here. Right. But what is easy to understand, what is easy to process, right? Because you see, if I use this particular equation for my calculation, it becomes pretty hectic because for each and every value there is a e to the power to be calculated and there is a 1 by root of 2 pi sigma square constant getting multiplied to this whole function, which makes things pretty complicated, right? So to avoid that, what we do, we go for something called as the standard, right? I'll write that now. So this is the one which we actually had plotted yesterday. So mathematics says that that is not a normal curve, that is a standard normal curve. Right? But in general, when we use it in statistics or maybe in the data science perspective, normal means the one which I'm plotting now. Okay, so just remember that, that's all. So this is mathematically called as the standard normal distribution. Right. So actually standard normal distribution is a special case of the normal distribution. What is that? Mean, don't write a mu, write it 0. Sigma square, don't write a value over there, simply write 1. That's all. Okay. So that's what is standard. So it's a still valid. You can simply call it as a normal distribution only. But mean 0, standard variance. So sigma square equal to 1. Substitute that, you get this. That's all. Okay. So now, so how do I get that? How do I come to that? From the normal distribution, how do I get the standard normal distribution? So standard normal distribution means, right, I have to have something like this. So the mean should be equal to 0. And when I try to write the sigma, it is equal to 1. Sigma square is also 1. Okay, sigma is 1, sigma square is equal to 1. This is my fundamental idea. So that means, let me try to write that now, so that, right, we will be able to look at the conversion. How do I convert? Okay, so say this is the x-axis and now the y-axis will be at the center, and along the y-axis itself I am measuring the function. Okay, so this is what we will call it as maybe I'll write it as a phi of x. Okay, so since I'm converting, I'll come to the conversion part later. So later on, I'll copy the same diagram to some other place and I'll write the proper notation. As of now, we don't have a notation with us. I'm trying to approximate things. Okay, so this is phi of x. What you are expecting? I am expecting at the x equal to 0, it should have a maximum value and then it actually comes down like this. Similarly, even on the other side, it should decrease and it should be like this. Now, this is what we obtained, right, in the when we plot it, right? So this is what we call as a normal. Yes, it is normal with the special case that mu is equal to 0, centered at 0, variance equal to 1. Now, so look at the previous. Normally, as I mentioned earlier, when you get actually a data set and I say that this is normally distributed, I am not getting this. It's not going to come at all. You need to convert. So how do I convert? Okay, before the conversion, let me show the other one first. So I have something like this with me. Okay, so I'll, right? So this is what we have. I want to convert this into the other one which we have shown just now. Okay, so how do you convert? The meaning is that every point should shift. So whatever is at mu will come to 0. Whatever is on the left hand side will go to the left hand side of my y-axis. Whatever is there on the right hand side will come to a point closer to this side. So that's what is there. So you see that you are shifting the curve to the left or right, depending on that. So in this case, it is you are shifting to left. So the shifting operation has to be performed on each and every point that is present on your curve. Agree? Right? So let's see how do you represent that mathematically. So already there is a x-axis, right? This is the x values. Now I cannot convert x into x. I have to convert x into something else. So that will bring your values on the right side to the left, so that you can move the mean central value to the 0th point. Okay, so let's try to do that now, right? So what I do now, I'll slightly modify. I told that I'm going to change this, so I don't want to copy. I'll make the changes here itself. So this is the standard normal. So let me call it by a different name. So my axis is not x. As I told, I have to map something. So something which is on the right should come to left, right? So that new axis, I'm going to call it as a z value, z axis, and let me change this to phi of z. F of that x is already a shifted version. I'm bringing it to a new position, means this is a new function. So just the notation changes, that's all. Nothing actually has changed. Only thing is that whatever function we have on the right, it is being moved to the left so that it becomes the standard normal. So how do you do that? What is the mathematical representation? How do you convert x into z is my question. So here, this is the simple operation. You see, the z can be obtained easily by doing this conversion. Okay, whatever x you have, subtract the mu from that and divide it by the sigma value. Sigma is anyway, I'm going to get a 1 value ultimately, right? So x minus mu. Please do that. What is the x value of the original function, the f of x, which we had considered earlier? I'll show you once again to make things clear. Right? That is the central value is at mu. Right? This is on the x-axis, x value. How do you convert this into z? Whatever is the x value, subtract mu from that. So mu is the central value. Subtract mu from that. What happens? Mu minus mu is 0. So you see mu comes to the center. Right? See the mu shifted to the center. Yes, Swapnil.
Sorry, in any example, any situation, mu is always 0.
Yeah, if you are talking about the standard normal distribution, this is the case. Always mean is 0. Okay.
Okay.
Yes. So we are converting that only, right? My intention is to see how do we convert any mu you have originally, like the first function which we have plotted. This will be shifted either to the right side or left side. You have to do this calculation so that it comes to the center. Then only we will be calling that as the standard normal distribution. Okay, so now we are discussing how do we convert. What is the equation to be followed? All right.
So, sir, here we are, z equals to x minus mu upon sigma, right?
Right.
So in this case, we are shifting towards left, right?
Okay.
And if we want to shift towards right, so then it becomes x plus mu upon sigma.
Perfect. All right. So now I'm taking one example and I'm doing this. You can do the other way as well. Okay, depending on the situation.
Okay.
All right. So that is how now you see simply I can just verify with the central value only, because other values I don't know. So I just look at the central value. Central value on the previous graph was mu. Subtract mu from that, it means my z value is 0. That's what I want, right? I want the mean to be shifted to the center. So division by sigma happens because whatever is your sigma value, originally distributed that variance, it gets divided by sigma. So whatever sigma you have, sigma by sigma, that becomes equal to 1. That's the idea. So we don't see that happening over here. So how the sigma becomes 1? By just dividing by sigma. You had some sigma there, divide by sigma, it becomes 1. Okay, so that's the that's how you try to represent. Okay, and simply this means you have converted your function into this. Now if you want to go back, in the sense, let me say I have a standard normal, but I want to go back to my original function. How do you do that? You can do this reverse, right? So simply calculate x now. So this means, this implies what is the x now. So use the, it's simple mathematics, right? Move the sigma to the other side and move the mu to the other side. Mu is negative, this becomes positive. So this is equal to sigma times z plus mu will give you the original answer. I hope this is clear. Now we can do a little bit of more mathematics. I skipped that part, right? How do you write the function in terms of z? Right? So writing in terms of z, you get this. So this implies the equation phi of z should be equal to 1 divided by root of, look at this, 2 pi sigma square. What is the sigma? It is 1. You don't have to write. Okay. Into e to the power will definitely come into picture. Okay. So that is e to the power, right? It's no more x, it is a z, right? Because x minus mu by sigma, right? So just look at the previous function, I'll show you that. Right? Look at this part, x minus mu by sigma. What is that? That is a z. There is a square outside that, so it simply becomes a z square, correct? X minus mu by sigma is what? Z. There is a square in the numerator, it's square in the denominator. So square can be clubbed all together to write it as a z. So what happens to your function? What happens to the function now? The function becomes simply z squared by 2, correct? E to the power, this is minus z squared by 2. So we started with the normal curve, which is centered at a mu and centered at mu value and having some standard deviation sigma. Now, if you are using the above said equation for conversion, that is this equation, you convert x minus every x value should be subtracted with its mean value, divided by the sigma value, you get a z value. Okay, now if you plot all these z's for the corresponding x values, you get this particular curve that is called as the standard normal curve. Okay, any doubt so far? I'd like to clear the doubts before we proceed. So please ask if you have any doubt. Okay, all right, that's good. So I hope you are understanding the concepts. Now let's proceed one step further. What is this? This is actually a PDF, probability density function. Okay, now if at all I have a probability density function, I can calculate the probability, right? Anyway, probability concepts are not at all discussed, so I'm not expecting a answer from you, right? It's not expected that you know everything, right? That's absolutely fine for me. Right, now I'll tell you how do you convert the probability density function into the probability. Okay, so this is the idea, right? So just remember one point. Anyway, we'll be coming back to this point when we discuss the probability. That time I will be discussing this in detail. But as of now, since I want this readily available, so I'll tell you the answer, right? So this is how you calculate. Let me say I want to calculate something like, what is the probability that this z value, you see along the x-axis, along the horizontal axis, we plotted a z, right? So now my intention is that I want to know that what is the chance that z1 less than or equal to z less than or equal to z2, right? What is the chance that the z lies between two of the values? for example, let me consider the same diagram. I will not write it in very properly. Just bear with. Okay, so this is the z-axis. This is the phi of z, and we know that this phi of z is something like this. All right. So out of this, I'm specifically asking the question that what is the chance that it is between z1 and z2? That is right. I'm talking about this particular area. Right? So go back to the basics of mathematics and try to answer me. How do you find out area under a curve? Nothing to do with the probability, nothing to do with the statistics. Okay. Go back to elementary mathematics, like maybe the PU level or +2 level mathematics, and try to answer my question. If I have a curve like phi of z, how do you find out the area under the curve? I hope the question is clear. Please put your answer in the chat box, or even you can answer orally. Right. Okay.
Integration.
Yes, that's right, Ruchi. So we have to perform the integration. When you integrate a given curve, you always get the area between that curve and the x-axis. That's what we are expecting here, right? So you see the diagram. I just mentioned that I want to find out the area under that curve between the z1, z2, and the area is between the curve and the horizontal axis. So that means you are supposed to perform the integration, right? So that's a probability, because see, this is what the from the probability we are using this. Anyway, I have not discussed that. I'll come to that part later, right? Why the integration of phi of z gives me probability. I'll come to that part later. I'm not discussing that. It will come, right? So, but ultimately, if I want to calculate this particular probability, then I have to do what is my equation now? You can simply understand. That means I have to do the integration of the above said function. That is integrate, right? That is z1 to z2. Do this phi of z dz, correct? Phi of z is this whole curve. Integrate between 2 points, z1 to z2, okay, with respect to z. So therefore I am writing the variable of integration as dz. I hope that is very clear. Okay, let me go one step ahead. Let me try to substitute the value as well. So this means there is 1 divided by root of 2 pi. It's a constant. I can take it out of the integration, right? So then do it z1 to z2, z1 to z2, and I'll write the same function e to the power minus of z square by 2 dz. Any doubt so far? Any doubt with whatever you see on the screen? Please let me know. Right? I'll try to clear that before I proceed further, because what we are going to do next is very important. Yeah. Any doubts? Please let me know. Okay, that's good. Right? Now I use a property. Whatever I see, right, I'll try to make it as a property. You see, right? I may want to calculate anything. I'll draw the same graph again, or let me copy that. That will save some time and it will also look neat. Right? So instead of drawing again, let me copy that. Okay. So I'll try to copy this part. Okay. I hope I'm going to get the clear. So copy and paste. All right. So this is my graph. Now I will use a particular property that I observed. Yesterday someone asked a question immediately after plotting this, right? It has a characteristic that whatever value is there on the right side, it is also present on the left side. Yes, it's an observation. Only when you do such observation, right, we can go ahead and we can make things simpler. Correct? So you see what area you have on the right hand side, it's the same as on the left hand side. Correct? So that means if you have a calculation for, let me say something like this. Okay, so let me say all right, let me say I want to calculate this value. So this is what I'm going to call it as minus z1, and on the other side I will have a plus z1. Correct? So if at all I want to do this calculation, okay, that is minus Z1 to plus Z1, the phi of Z dz, I know that I don't have to do this minus Z1 to plus Z1, right? Because this function is a even function. Have you heard of, in mathematics, somewhere you might have heard of even function, odd function, etc. Okay, anyway, I don't want to touch that. If you remember, it's fine, right? This is nothing but if you have both side, right? It's like a mirror image. I have whatever on the right side. I have something on the right side. I place a mirror here. I see the same thing, mirror image on the other side. Such functions are even function. Even functions have a property. That is, you want to calculate from minus a to plus a. Don't do that. Simply do 2 times 0 to z1. Because whatever area you have here, it's replicated on the other side, right? So don't do the other calculation. Simply calculate 0 to z1 and proceed. Multiply that by 2. So, right, we make that observation for this particular function. Now you see the advantage of converting the x into z. Okay, because x was located somewhere. If you want to calculate from some point to other point, you have to do the complete integration, and that function was pretty complicated. Compared to this, that is complicated. This is, I'm not saying that this is easier. It's still difficult, but not as complicated as the other one. Okay, makes sense? All right. Now, so that means I can write it as 0 to z1 into phi of z dz. Agreed? So far, any doubt? I'll still wait. If you have any doubt, please clear that. Then we'll proceed further. Okay, no doubt? All right, that's fantastic. Now, right, now the important part which I mentioned that, right, something important is going to come. We are entering into that particular section. All right, so that is what is called as the standard normal distribution related problem. Now you see, in order to solve the probability, right, if I want to calculate, so actually you see here, this is actually, I didn't write the what I'm trying to calculate. I'm trying to calculate the probability that, right, the, sorry, let me write it clearly, minus z1 less than or equal to z less than or equal to z1. You see, I'm actually calculating the probability from the standard normal curve, right? But in order to do that, what is the procedure in case of a continuous distribution? You have to integrate. This is actually a very difficult job. It is impossible, right, to do this manually within a stipulated time. Let me say I give you 5 minutes time, solve this. Impossible. It will take a lot more of that time than that. Okay, so continuous distribution I want to solve means there is only one way, that is to refer what is called as a standard normal distribution table. Okay, so please search, everybody please search on the internet that the normal probability table. Okay, standard normal probability table. I'll just write here so that you can search that. Right, so this is the important part. We are going to use this to solve the problem, that's why. So please search the standard normal probability table. Everybody please search, use your browser and search this. You will get a table. Okay, so the table what you get should be of the following characteristic, right? You will have, say, z written over here, right? You will have the values like 0.00, 0.01, 0.02 dot 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 up to 0.09. That will be the heading. Okay, again on the left side we are expecting 0.0, 0.1, 0.2, 0.3 dot dot dot. Okay, maybe the last value is something close to 0, close to 3.0, or close to 4, close to 5, anything is fine. But right, there are many other versions also. So just to bring uniformity, you try to find one graph which looks something like this, and you have the values written over here. Here you have a value like that. Okay, so another value, right? Like a table. Okay, so left hand side you have some values, top side you have some values, and below that in the form of a table you have many numbers written. So normally this is what you see, standard values. Something very closer is also fine for me. Okay, so I am looking something like this. I'll write some of the values so that you can verify what you are getting on your table. Okay, so this is 0.0000, this is 0.0040, the next value is 0.0080, and so on. Okay, so the last value I'm expecting is close to 0.0359. Okay, so again below that I'm expecting 0.0398, and you have many values. Around 3 I'm expecting 0.4987. just verify whether you are getting whatever table you obtained when you search is similar to this. Okay, you have many values coming here. Everywhere you find the values. Okay, like this you have many values written, right? Like that. I want a complete table. This is the table we are expecting. That table is what we call as the standard normal probability table. So what is the meaning of the numbers written over there? I will explain in a while. So let us take 1 minute of time so that everybody is ready with this kind of table. Okay, again I mentioned there are other tables as well. Okay, if the table you are finding is not similar to this, some other type of entries are there, right? Please don't consider that. I want the one which is similar to this. Okay, this version will definitely come when you search.
Yes, sir.
Yes.
I found out this table, but it start to like 0.5.
Sorry.
In first value of 0.0, this table start with a 0.5 value.
Okay.
Is it correct?
Actually, there is a small difference with the one. We are expecting something similar to this because what I am going to teach now, we'll use this table as a standard. Okay, normally we use this as a standard one. Please try to find out any other table which is similar to this. Okay, so I think Gaurav has shared one thing. Please try that. Okay, so click on that. Mostly that will give you the similar table. Is it Gaurav? Are you referring to the same table which I have written here?
Yes, sir.
Okay, so please everyone follow the link shared by Gaurav. Thank you, Gaurav, for sharing. Okay. All right. So we have this table readily available with us. Okay. Please follow the link given there in the chat box. You will get the table. Okay. Now let us come back. Let's come back to the table after a maybe 1 or 2 minutes. So let me go back to the one plot which we have considered. I'm going to paste the same thing again. All right. Right, so you see this is the phi of z, and we know that it is a probability density function. In the sense, it's something like at this point what is a probability, at this point what is the probability, like that it is a value. Okay, so now I'm going to ask you a very basic question. If at all this plot was discrete, I know that the sum of all the values when you add together, that is equal to 1. Agreed? Sum of all the probability is equal to 1. Now I'm asking the question. My question is that what do you get if you integrate this all the way, all the values, right? What you get? What is your answer? So my question is, I'll write my question. So what is the answer if I integrate from minus infinity to plus infinity? The phi of z dz equal to how much? Okay.
1.
Yes. So that is 1, because integration is addition of every number that is present on a continuous curve. Correct? So yes, that's right answer. So this has to be equal to 1. All right. So why I ask this question? Because there is some trick that we can use. That is 1. So it means integration of this curve from minus infinity to plus infinity is 1, means I know that this curve is symmetric. Correct? So what is the integration of 0 to infinity? Can anybody answer that? So if I change this integration 0 to infinity, phi of z dz, how much?
0.5, sir.
Should be half, right? Because it is symmetric. Already we discussed that, right? Absolutely perfect. So that means even if you consider only half of the value, 0 to infinity values you calculate, you will be able to calculate the other half easily by simply multiplying by 2 or doing something similar to that. Agreed? Okay, so let me write that point here. Before that, let me erase what I have drawn. Okay, so this is the first point. Anyway, you understand that. Also, I'll write integration minus infinity to 0 phi of z dz is equal to 0 to infinity phi of z dz is 0.5. Okay, fine. I'll move ahead. I'll move one step further. So this means integration means what? Integration of phi of z means it is a probability, correct? So can I write the following statement? Just check this. So the probability that I have a z value between minus infinity greater than z less than plus infinity. Can I say that that is equal to 1? Because this integration means the same thing, right? Just now we have previously written something. Okay, before the table, you just refer, right? You see here, probability between minus z1 to z1 means I should integrate from minus z1 to z1. If I replace one of them by 0, it's obviously correct. It's obviously, it should be valid. Okay, right? So similarly, I can write, therefore, probability minus infinity less than z less than 0 or even equal to 0 is fine, is equal to probability that 0 less than z less than plus infinity, that is also half. So from the standard normal curve, we are trying to extract more and more information. Whatever is standard I am writing, whatever is not standard will refer to the table. That's why I asked you to keep the table ready. Okay. Are you fine with this? Okay. Now let me ask a slightly different question. Okay. Now, what is the probability that z is greater than 0? Can anybody answer?
0.5.
The 0.5 minus
0.5,
probability.
right? Because z greater than 0 means 0 to infinity it is valid. So yes, that's right. Everybody try to answer, try to understand this, right? Pretty important. Okay. Then similarly, I can ask what is z less than 0? Again, you will say, okay, pretty much valid. I am not going to write that. Now, let me say, so what is the probability that the value of z is lesser than a specific value z1? Okay, here I am going to specify z1 is a positive number. Okay, z1 is a number is not required, it's just a positive value. Okay, so it's a positive value. So how do you calculate that? Look at the curve.
So P of 0 to Z1 plus 0.5.
Right, absolutely perfect, right? So let's go back just to answer that. So whatever he answered, I'm trying to explain that. So it is given that this is a z1, right? Z1 is positive. That means the value of z can be anywhere before this, right? Z1. So that means it can be present all the way from minus infinity till here, correct? Out of which this part I know, this part is half. Whatever is on the left side, half. And 0 to z1 should be added to that. Agreed? Right. That's the answer. So if you have doubt, please ask me. I'll explain that again. But first, let me write the answer once. So whenever the Z1 is positive, right, I am supposed to do this calculation. So let me erase the Z1 because I'm going to use this graph again. So that means if I want to calculate this, all the way from minus infinity to 0, I should calculate plus 0 to Z1. So this is integral minus infinity to 0, the phi of Z dz plus 0 to Z1, right? Phi of Z dz. But the left hand side, I know that is 0.5, correct? Plus, and only I have to do 0 to Z1 phi of Z dz. Okay, why 0.5? Anybody has any doubt, please let me know. Explain once again. Okay, so that means it is very clear. All right, so I will say let's do one more thing. Right, what is the chance? Once again, this is my question. Probability of Z greater than another value Z2. I'll keep Z2 positive. Anybody?
So almost the similar formula, but we calculate this and then we subtract this from 1.
Okay. Is it necessary to subtract from 1, or if you can reduce that? Is there any chance? Think about that. Meanwhile, I'll try to draw. Okay. So this is my question. I have a Z2 somewhere here.
Okay, so 0.5 minus
Z2 to infinity.
Z2.
Right. So my question is that I want to calculate what is the chance that it is more than Z2. I want some value which is more than Z2. Okay. But what we do when we calculate, we always get this value easily. Okay. 0 to Z2 you can get easily. How? Anyway, so we downloaded the table. Keep the table ready. Right. Next class we are directly starting with the table because time is out now. I'm going to finish within 1 minute. Okay, so everybody keep the table ready, download it and keep it in your some folder. Okay, right. So now the idea is that I want to calculate more than Z2. So as one of the answer I just got now, you have to do Z2 to infinity. But doing that is bit difficult, right? So what normally we get from the table is that 0 to Z2. Okay, so that means, anyway, I'll write the answer directly. With that, we'll wind up. Okay,
0.5 minus P0 to Z2.
Yes. That's the answer. Okay, so positive. That means normally I'm supposed to do Z2 to infinity phi of Z. Okay, this is what is required. But other option is that I know that right hand side is 0.5. So from the complete 0.5, you subtract 0 to Z2. So that is 0, sorry, this is not 6, this is 0, 0 to Z2, phi of Z dz. Now, some of you may have a question that why do you do this? This looks difficult. So 0.5 minus something you do which is 0 to Z2, it looks difficult. But once I touch the table part, this becomes pretty easy, pretty clear that why do you convert this in, why did we convert this into this form? All right, why we converted into this form? It becomes more clear when we start looking at the concepts under the tabular method. Okay, so along with this, we have many more methods to come to calculate various values between Z1, Z2, between minus Z1 to minus Z2, etc. Many things will come into picture, right? Before that, right, I want you to get adjusted to what we have discussed today with respect to the standard normal distribution. All right, so I will be sharing this material today itself. You may get at the worst case tomorrow morning or maybe today late night. All right, so please go through the concepts we discussed today and get ready for the upcoming session. All right, before that, is there any doubt, anything you want me to clear?
Hello.
Yes, Swapnil.
Sir, do you have any kind of PDF notes available on this
I'm sharing
normal
this
distribution?
everything what we have written here will be converted into PDF and you will get it. Okay.
Okay.
Yes.
Thank you so much, sir.
Yes, sure. All right. So this material you get, everything I have written here, immediately you will get it in the PDF form. You can refer that and you can understand whatever we have done. Yes. Next question.
ओके सर, ये जो भी है थोड़ा समझ पाए थोड़ा और थोड़ा प्रैक्टिस करेंगे तो होगा सर ये घर में.
Yeah. So needs practice. Get some standard textbooks which solve many concepts on this. Okay. So practice more, you will be adjusted to. All right.
Sure.
Hello, sir.
Yes. Please go ahead.
Yeah. Actually, I think this probability matrix, probability, and all those things we have learned in primary education, 10th and 12th. I think.
Okay.
So it's, I think we forgot most of things, right, sir? But my question is, we need to memorize all those formulas, sir, and it is going to use particular data science, sir?
Yeah, probability and the statistics are the fundamental steps in the data science. When you look at the data science view, right, this is the first step. You may not be able to recall each and everything. That's fine. Okay, but you should know that, okay, probability of calculation of probability uses these kind of formula you can actually download, you can refer internet and you can get the formula, not a problem with that. But you should be able to remember that, okay, there is something like this, like, okay, when I say a distribution, you should be able to remember, okay, there are two types of distribution and there are categories under each distribution. There is a Poisson distribution, Bernoulli's, there is normal, standard normal, etc. These terms should be coming into mind. Okay, that's the fundamental idea for teaching this under this sessions in initial phases of mathematics. Okay, so you should be able to recall at least, not the exact formula, that's fine. Everybody cannot remember each and every formula present over there, but what is expected is that you should be able to remember, okay, there is something called as normal and this looks like this, and the formula, at least formula is of this formula, something like 1 by 2 pi e to the power something. You should be able to recall at least that.
Yeah, terminology we should know. Ultimately, we will program. We will put some value and
everything will be programming. Okay, we are never going to do the mathematics for 10,000 data sets. But when we have a simple numbers like this, how do we do the calculation? If you know, you can extend that and write a code. Okay.
Yeah, so we need to understand the terminology and the concept how this value came.
Yes.
Basically, when we program. Right. So we need to understand how this value came.
Yes.
Right, sir?
Yes. Perfect.
Okay.
That's right. Okay, practice more. You will be getting adjusted to that very soon. All right. So, any other doubt? Anything to discuss? Okay. So I hope this session is useful to you. I expect people to practice more problems. Take some standard textbooks where you have more problems on these kind of concepts. Practice more and you will be adjusted to that. Okay.